Good evening, everyone. I'm Dr. Cheryl Holder. I'm co-founder and executive director of Florida Clinicians for Climate Action. Thank you for joining us in our second in the series of Heat and Health for more in Central Florida, but pretty much all over Florida. This program is funded by the generous donation from the Allegheny Franciscan Foundation, and we are here to educate as many people as possible, especially clinicians, on the health harms of climate change, especially heat. All attendees will receive an email request 1 hour after conclusion of the presentation to evaluate tonight's course. Please, please, please just take a few seconds, few minutes to complete the short survey. We really need your feedback. And also, you get nurses qualified for CEU, and that will be sent by email that you use to register for this session within 7 business days. We'll also have a Q&A after the presentation, so please type your questions through the Q&A. There's a Q&A section, type it in. If you are so moved and you can't type it in, then if you can come on, then we'll let you on, but we really want your questions because that's really how much we learn. So for tonight, we have our meteorologist, Nkose Moose. He's with the University of Miami. He's on his way to getting his PhD. As a matter of fact, he's going to defend in 2 weeks or so. Mr. Nkose Moose, Environmental Science and Policy PhD candidate, University of Miami, Rosenstiel School for Marine, Atmospheric and Earth Sciences. And he's a trained meteorologist, a Bachelor of Meteorology from UNC Charlotte, Master of Geoscience and Climate Policy from Georgia State University. He's very interested in ensuring that our cities are equitably prepared for the implications of climate change, with a particular focus on extreme heat. And thank you, Nkose. As we said, I'm Dr. Cheryl Holder, co-founder, executive director for Florida Clinicians for Climate Action. We've been around since 2018, and we have done many work in Miami-Dade County, and we're extending our work in Central Florida now and eventually onto the West Coast, and all through to have folks understand the implications. And tonight's session, Nkose will start and giving us an idea of what climate and what weather and why we call it climate change and what you have to understand. And then I'll come on and give you a brief summary of the many ways that this can happen. This is just a teaser for you to understand how much impact we're experiencing now and in the future, and then join us for the rest of the year, every month, for another series where we dissect each of these topics in more depth. So thank you for joining. Remember the Q&A, remember to send your feedback and your CEUs. So with that, Nkose, you're on. Thank you.
All right, so good evening, everyone. My name, like Dr. Holder said, is Nkose. Feel free to call me Kos. That's what I have been going by here in South Florida. I'm a meteorologist by training, but also, like you said, I'm a PhD candidate at the University of Miami too, studying environmental science and policy. So my expertise is in the actual dynamics of the atmosphere, how that interacts with the surface, and things of that sort. And I'm going to apply that to talk a little bit today about global warming and heat hazards. And one thing that I really want to parse out and make sure everybody also understands is that global warming and climate change are actually two completely different things. We hear them interchangeably a lot. We hear about climate change, we hear about global warming, but one thing I want everybody to understand is that global warming is actually what is causing climate change. So throughout the course of this presentation, there's going to be a decent amount of pictures, a decent amount of maps. I'm not sure if we're able, if guests here are able to unmute and throw in questions and things like that, but I'm happy to pause at any point if you see a slide or you see a graphic that I'm showing and it doesn't really make sense or I didn't explain it well enough. I say all that to say because I like to have conversations about some of these things rather than lectures. So yeah, I don't really like text, so I like to show pictures. So you'll see a decent amount of maps and pictures, and feel free to ask questions about them at any given point. So starting off, let's just go back to 1 million years ago and think about carbon dioxide, which is a gas that we have in the atmosphere. It's naturally occurring, but it's also a significant gas I don't want us to think about because it is the primary greenhouse gas that humans emit from our cars, from our homes when we use heat, natural gas, things of that sort, from airplanes. all the human activity is producing large amounts of carbon dioxide. But for the past 1 million years, if you can see my mouse, I'm over here at 800,000 years ago. You see that the carbon dioxide was relatively high. And then up until about 50 years ago, 70 years ago, we had this natural oscillation of CO2 going up and down about every 100,000 years or so. And in the times where CO2 was high, like for example here, that was because we were in what's called an interglacial period, meaning the temperatures were high enough so that the Earth essentially was not in an ice age. So all of the ice was melting. It let go of a lot of the gases into the atmosphere. So the CO2 increased. The concentration of CO2 in the air that we breathe increased. But then when the ice age came around, which happens about every 100,000 years or so, all of that gas that was in the air gets frozen in the ice caps. And when that happened, we would see a decrease. So these low levels of CO2, that's what that would correlate to. So we had this natural oscillation of CO2 for the past 1 million years. Every 100,000 years or so, we go up and then down, up and then down. But now we're at this level and it's really beyond this. We're beyond 420 parts per million of CO2 in the atmosphere. And I'll explain why that's important. But it's also not just CO2, it's also methane and nitrous oxide. Methane is more so organic gas. You see a lot of it from farming. It's something that is also emitted as the ice caps melt. The natural gases from the actual ground are emitted. It's methane. Nitrous oxide is a pollutant that comes from a lot of our factories. Those two gases are also increasing in concentrations along with CO2. That has come about with the Industrial Revolution and then our secondary Industrial Revolution that we are also experiencing. Now, I mentioned methane and nitrous oxide because they're actually more potent than carbon dioxide. And I say, what I mean by potent is they actually are stronger in the effects that they have on trapping heat in the atmosphere. So you're probably wondering, like, why am I bringing up CO2, nitrous oxide, these weird acronyms that I know nothing about? Well, the more that carbon dioxide goes up, the more that temperature goes up. And you also may be wondering, if you look on the left side, you see the temperature, the increase that we've seen. And then on the right side, you see in parts per million. So essentially what that means is for every million particles of the air, we have about 410 parts per million. 410 particles of that air are actually carbon dioxide. So it doesn't seem like a lot, but in the grand scheme of things, it's what's causing the Earth to get warmer. And you also may wonder why 1.1 degrees Celsius, or in this case, almost 2 degrees Fahrenheit, that's not enough, right? How does, 65 degrees feel any different than 67 degrees? Well, this is the average global temperature that we're seeing across the entire globe. So that average temperature increasing is causing massive shifts in how we experience climate, how we experience weather as we know it. So all in all, the greenhouse effect is the main thing that is a result of these what are called greenhouse gases, CO2, nitrous oxide, methane, because they essentially trap heat. Now, the greenhouse effect is not a bad thing. We're supposed to have the greenhouse effect. In fact, it's actually what prevents us from freezing to death because the atmosphere has these gases in it. It traps some of the heat and it keeps us warm. So even if you are in DC right now and it's like 10 degrees, that's better than the negative 100 degrees that you experience if there was no atmosphere per se, right? But the problem is the greenhouse effect is now on steroids, meaning we've put all of these additional gases into the air, the CO2, the methane, the nitrous oxide, and there are actually more greenhouse gases. Those gases are trapping more heat. So essentially what is happening on the left side and the right side, the sun emits its rays. It takes 8 minutes for the sunlight to get from the sun to the Earth's surface. Once that happens, it is able to pass through the greenhouse gases because it's of a certain wavelength. So that sunlight that's emitted is of a certain wavelength that it can pass through the gases, reach the planet's surface. Then the planet's surface absorbs this heat, absorbs this energy, and when it does it, it transfers it into something called long wave radiation or infrared radiation. And when that's re-emitted, that's not something that can pass through the atmosphere or pass through many of these gases. So the more of these greenhouse gases that we have, the stronger the greenhouse effect is, and the warmer the planet gets at a faster rate. Now, this is important because it modifies something called the jet stream. Now, many of you probably are not familiar with what the jet stream is. You may have heard of it. It's been somewhat in the press a lot recently because it's been changing with climate change and with global warming. But the jet stream is something that actually dictates a lot of our weather in the United States. It's what carries our weather from the West Coast all the way to the East Coast. In fact, if you're on a plane, you're actually flying in the jet stream most of the time. If you're going from Miami all the way to California to Los Angeles, you're flying against the jet stream. So if you ever look at your flight time and you see why it takes me 6 hours to go from Orlando or Miami all the way to LA, but then it takes me 4.5 or 5 hours to go from LA to Miami to Florida, that's because you're actually flying with the jet stream and it's actually giving you speed. So the jet stream goes at very, very fast speeds, maybe 200 to 300 miles per hour, carrying our weather patterns across the United States. But the issue is the jet stream is usually very stable. It exists miles and miles above us in the atmosphere, and it's becoming unstable because what it does is essentially serve as a barrier between temperature. So on the north side of the jet stream, essentially here where you see the ice caps, the snow, and then the south side of the jet stream down here in the United States, it's separating that Arctic air from that warm air down below. So it's essentially is like a temperature barrier. And the thing is, as the globe warms and the jet stream gets confused because it's like, okay, well, it's warm over there now. It's also cold over there now. How do I accommodate for that? We start to see a waviness in the jet stream, and that waviness is what's causing so much of these weird weather patterns that we see. And it's especially true for when we experience something like heat waves. So more specifically, when we're looking at heat waves, it's happening during an event where we see some type of a phenomenon called a heat dome. Now, I'll dive into that a little bit deeper. But when we have a jet stream that allows the cold air to be pushed up, further up into the atmosphere, and then that warm air from the tropics is able to funnel itself all the way up into the United States, that's where we start dealing with these kind of extreme heat events. So what you see here is a visualization of the jet stream really across the entire planet. And we're going to zoom out, stay zoomed out for a little bit, and then eventually I'm going to zoom into Florida. But what we're seeing here is, again, the jet stream getting wavy over certain areas. And then when we have this kind of concave effect, also known as a high pressure heat dome, that's when we see these extreme heat events, because essentially all that cold air is being trapped up north, and then we have the warm air funneling in down south. So if we zoom in even further and we look at how the heat dome operates in the United States, it's bringing in a lot of that Pacific air, or excuse me, that Pacific moisture all the way from the Pacific Ocean, dragging over into the United States. And then at times, some of the moisture is getting blocked by the mountains, so we could see very humid temperatures, maybe in Phoenix or something like that. But at the same time, on the east coast of the United States, the Gulf of Mexico is also a big product of why we experience so much humidity on this side. So that moisture funneling up from the tropics as well through the Gulf of Mexico is also making it very, very humid and warm on the east side of the United States. And I won't dive into the jargon too much here because it can get really confusing. But essentially, heat domes are phenomena that are caused by high pressure systems. So in a high pressure system, it's not a bad thing. A lot of the times when we experience a high pressure dome or we experience high pressure systems, it actually is allowing us to experience good weather. It's keeping a lot of the clouds out. It's keeping a lot of the rain and everything that would come in. So we may experience a nice sunny breezy day. But as climate change intensifies, global warming intensifies, we're starting to see these heat domes get very, very, very intense to the point where now the heat is trapped in and we can't let it go. It's not being allowed to flow outward. And we're seeing these heat domes last for longer periods of time too. And it's becoming a very significant threat, especially in the western, central, and even eastern United States. So all in all, this weakening jet stream from what is supposed to be this normal circular and stable pattern across the globe is now becoming wackier because it's confused. There's these imbalance in temperature, and essentially what the Earth is trying to do is achieve balance. But when we're throwing this balance off by these additional greenhouse gases that are going to the atmosphere that are also making everything warmer, it's changing the weather a little bit and it's giving us these temperature extremes that we experience. Now, there's actually multiple jet streams. We have a polar jet stream, the one that keeps the cold air up top, and then we also have a jet stream, a subtropical jet stream that moves up over the United States during the summer, and they're both becoming wavier. So this is an issue on both fronts. Now, if we zoom in a little more into the United States, overall, we're seeing that there's an observed temperature change increase for the most part across the United States. So everywhere you see warm colors here, that's where the temperature has been increasing over the past 100 years or so on average. There's some cooler spots there, but even then, they're not exempt from the impacts of extreme heat. Something that really pops out here on this map also is South Florida and Central Florida. You see how warm, you can even see Orlando, that red blotch there in the central of the state, right above that circle, that white circle in the middle of Florida. That's Lake Okeechobee. Right above it, you see Orlando and that urban heat island effect that pops out. So we have this overall increase in temperature, but we're also experiencing high amounts of moisture. So this graphic shows you essentially how much moisture is in the air throughout the course of the summer for the past 5 years on average. And what we're looking at, the warmer colors are indicative of higher moisture. So the redder it is, or excuse me, the warmer it is, the orange, the reddish colors, those are when we have higher moisture. And you can see that Orlando down into South Florida are experiencing pretty decent high levels of moisture, even the Gulf Coast, all the way over towards Texas as well, right? But something I also want to point out and delineate is that we experience this humidity for longer than much of the rest of the Gulf Coast does. New Orleans, for example, it's snowing in New Orleans right now. It's not snowing in South Florida. And it has a lot to do with the fact that we still experience tropical weather for longer throughout the course of the year. Now, another factor that's also really important is the urban heat island. Now, if we zoom in into this map, this is a map that shows land surface temperature. So think of land surface temperature as walking over asphalt on a really, really hot day where there's no clouds, the sun is just beaming down on the pavement. You probably don't want to be outside barefoot on that pavement, right? The same goes for grass. You may want to walk on grass barefoot, because it doesn't absorb as much heat throughout the course of the day, but pavement, on the other hand, is really warm. So that's exactly what's showing on the screen here. You see the darker redder colors those are indicative of higher temperatures that are also associated with urban development. So I'm not sure if you can see my mouse here, but if you can, I'm circling this area in the north central region of Florida. That's Orlando. That's an urban development, urban heat island. We can also look at St. Petersburg on the west side, also an urban heat island, Tampa, urban heat island. But the most prominent one here is on the southeast coast. That's the West Palm, Fort Lauderdale, Miami Beach metropolitan area. And you see that is really developed. All up and down that southeastern coast, we're experiencing an urban heat island effect as well. And the urban heat island effect, all in all, is essentially this urban development changing the energy balance of how we experience temperature, weather, you name it. So in downtown areas, we experience these warmer temperatures because that surface is absorbing a lot more heat throughout the course of the day and then letting it go at a faster rate at nighttime, or even sometimes a slower rate at nighttime. But then you have areas with more trees, the suburban areas, the urban residential areas, the farm areas, the rural farmland areas. They don't absorb as much heat throughout the course of the day, and for that reason, they're cooler. Now, there's also an equity component that plays into this. What you're looking at here is a federal housing security map, or a Homeland Security Administration map that shows essentially what segregation looked like in the 1930s. So technically, the name for this, we see these red blocks, is redlining. And you can see that in these redlined areas, that's likely where black and brown people were secluded to. And as a result, there was disinvestment in these areas. And as a result of that, there was less tree canopy, less heat resilient infrastructure built, and people experienced climate hazards differently in places that are redlined. So this is a redlining map of Miami, to be exact. You can see that Miami Beach, the green and the blue on that quarter to the east side of this picture. That's because those are the areas that are affluent. Those are the areas that people were, that essentially white people wanted to live because they had the means to do so, and because they didn't want black people or brown folks or immigrants near them. And then here in the central Miami area, that's where a lot of the black folks were relegated to living. The Little Haities, the Liberty Cities, the Allapatas, even the Overtowns, and then also the West Grove area. So for those that are familiar with Miami, that's a little bit of the history of how that has shaped something that looks like this. So again, this is a map that shows per census block group land surface temperature across the Miami-Dade County area. And in the city of Miami, like I was showing you before, those areas that were relegated to, the black and brown populations because they were redlined, they experienced the warmer temperatures. Those warmer colors are indicative of higher land surface temperatures. And that has a lot to do with tree canopy. So on the right side, you're looking at census block group greenness. So a measure of how green these areas are. And again, that same region in Miami, you see that there's browner colors indicative of less tree canopy, less greenness, which would imply higher land surface temperatures, and that correlates strongly across these two maps. And this is something that we see across really the entire United States. This is a map also that shows census block groups and then land surface temperature in these respective census block groups. And the ones that are coded, or outlined in darker black colors, are indicative of areas that are socially vulnerable. So our low-income communities, our communities that don't speak English as their first language, that have less education per se, that are black and brown. You see that the red colors, which are indicative of the highest land surface temperatures, are really only in these black outlined census block groups. And that's also indicative of the fact that there is a social vulnerability that is affecting how people experience heat in many urban areas. And this is the Baltimore urban area, to be exact. Now, if I flip the script a little bit, and then I'll come back to this picture, but very briefly, I just want to explain what this image is looking at. Again, you're looking at the Florida Peninsula as a whole. And then on top of it, firstly, you see the Florida Peninsula and you see the nighttime land surface temperature, those colors underneath. And then we also have circles above it that are displaying how much humidity is measured at each of those weather stations across the Florida Peninsula. And you can see that the darker the blue circle, the more moisture is measured at those stations. And we see more dark blue circles here in South Florida, which makes sense. We have higher humidity in South Florida. But even in Central Florida, the St. Petersburg area, it's a coastal region. It experiences higher humidity levels as well. Something that's also important to note is the inland areas are experiencing lower humidity values. What does that mean for heat per se? All in all, regardless, though, we're seeing an increase in temperature, heat index, which is a measure that combines temperature and humidity together. And then also dew point. Dew point is essentially a measure of how much moisture is in the atmosphere. The higher the dew point is, the higher the moisture is in the atmosphere. All of these are increasing together. So what does that mean? It means that in places that are coastal, we're experiencing higher humidity. That could lead to an increased heat threat. And even in the central Florida areas, for example, Orlando, they're experiencing higher humidity. They're also experiencing increased temperatures as well, especially being that they're in the middle of the state and they don't have any type of sea breeze. So mentioning sea breeze is essentially the result of an imbalance between the land and then also the ocean. So because the land is warmer throughout the course of the day, or normally is warmer throughout the course of the day, there's an imbalance because the sea is cooler throughout the course of the day. And essentially to reach that balance or at least that equity, the earth creates a breeze that goes from the ocean to the land. And as a result, you feel cooler. You have that sea breeze throughout the course of the day. You can even feel it at nighttime too, because the script flips. Now at nighttime, the ocean's warmer because it absorbed all that heat throughout the course of the day, and the land is cooler. But this is changing, and it's changing because the oceans, just like the temperature of the globe, are also getting warmer. And as that happens, there's going to be less of a balance between, or less of a gradient between the cooler ocean air and then the land air. So as the oceans are getting warmer and warmer to the point where we're seeing almost 99, 100-degree temperatures. Now, I mean, those temperatures are sometimes warmer than what we experience on in the air over land, right? So if that is happening and the ocean per se is 100 degrees and the land is about also 100 degrees, that cancels out the sea breeze. So essentially, you just have this humid air mass just sitting there, and it does nothing for how people experience coolness or how they cool off throughout the course of the day, and it makes it even worse. So in a place like Miami, that sea breeze is starting to become irrelevant, especially because we have these super warm temperatures, like I showed you here or there, on the water, but then also on the land. So that's happening in the daytime, but also at nighttime, because urban areas can be warmer. That urban modification of the environment, it changes how the land is supposed to be cooler at nighttime, and that warm air that's coming from the ocean that's supposed to be warmer at nighttime is also eradicating the balance. And as a result, we don't see as much sea breezes in these nighttime areas as well, or excuse me, these urban areas as well. And now places like Orlando and Central Florida, they don't have any sea breeze to begin with. So if you're walking around Disney World, you're walking around Universal Studios throughout the course of the day, unless there's some type of large lake that's there that's cooling off the area, you're probably not going to experience any kind of sea breeze, and you're just at the mercy of whatever humidity is present at that time of day, as well as the sun beating down on you at that time of day. And that's why what Dr. Holder is going to talk about following this presentation, this is so important to be able to recognize whether or not you are actually at risk of heat throughout the course of the day. So all in all, Earth's weather and climate operates in a balance, right? And global warming is unfortunately changing and throwing off how we experience this balance, and it's resulting in climatic changes. Now, heat extremes or heat waves are a result of this, but also an increase in humid heat, which can last throughout the course of the daytime and the nighttime, are also increasing. I showed you that graphic that shows how temperature, humidity, and the heat index are all increasing together over time. Urban heat islands make this effect even worse. They intensify the heat, and they're warmer than the surrounding rural areas. And then in urban areas too, these socially vulnerable, marginalized populations are more exposed. And I think Dr. Holder will get into that even further. And then lastly, inland areas, they experience warm temperatures with minimal regulation because they don't have this sea breeze. But also coastal areas can experience this sea breeze with this chronic humid heat. But the thing is, as ocean temperatures are getting warmer, we're seeing that sea breeze weaken essentially. So we may not be experiencing the same kind of relief from the cool air over the hot air that people, in most coastal areas such as Chicago or even up north in New Jersey along the East Coast may experience because they have a stronger gradient in temperature of the water. So with that, I'm going to stop sharing my screen and I'm going to pass it off to Dr. Holder.
Thank you, Nkosi. That was excellent. Thank you for the summary. Well, I always start my talks off with Anna Mae. Does everyone hear me pretty well? I met Anna Mae. That's not her picture, but it's somebody, she reminds me so much of her. I worked in the Opelika area, North Dade Health Center in Miami, Florida for many years. And this woman came in who was regular patient, really does really well. But this was a July in 2016, and it was the hottest July on record back then. And she came in, walked in because she needed her refills for her COPD asthma. And as she was leaving, she also asked me to complete her power and light bill because she needed some assistance because her bill was too high, she couldn't pay it. When I delved into it more, She had been so hot that summer. Her asthma was acting up. She was buying her refills. She was decompensating, all because of the heat. And with that, I started getting the understanding like what you're seeing about that Earth's atmosphere. And I started, what really is heat? And we know heat, and you heard what greenhouse gases, but think of heat as all these molecules that you saw, the carbon dioxide, the methane. And because energy is always just transformed, it doesn't eliminate, all these molecules are like vibrating, vibrating, vibrating. And as they vibrate, they create that heat. And that traps us. And that's like putting the earth with a big fleece blanket all around it because all these molecules are vibrating, because that's what heat does. It's energy and the vibration that generates the heat. Much like when we go out and exercise, we cause all that vibration and our bodies heat up. So our atmosphere is heating up. And 2024 was the hottest year on record. And as you saw what Nkosi showed, that the nighttime temperatures are much more higher, more extreme, and that's where we feel the sensitivity because that's where my anime couldn't sleep at night either because it was so hot. Where is it coming from? Our transportation, all the cars, the trucks, the buses, the airplanes, transportation drives a lot of our CO2 production. Then the next area, especially in Florida, is electricity generation. All the liquefied natural gas, what we use to generate electricity, makes a lot of pollution. Then all the factories and agriculture and farms, and then the buildings themselves as we make them. And you heard about the heat islands and all that concrete. All of that creates so much more CO2 and gas. We're doctors, nurses, we're part of the healthcare system. The healthcare system is a tremendous abuser and polluter. When you think of when you do one procedure in the hospital, what do you see? We use a lot of gowns and plastic bags and single use items, and we do single use utensils and trays, and a tremendous amount of greenhouse gases comes from the hospitals, which results in unnecessary deaths around the world. But the heat itself, and we talk about heat causing climate change, but heat itself has direct impacts. The air pollution has direct impacts on our health, and it drives at extreme weather problems. But also the heat and what happens to the rest of the planet, and it becomes a threat multiplier. So, besides just being the physical impact from heat illness, any kind of heart and lung problems get worse, and anime COPD got worse, and people's heart attack gets worse. Because of the pollution, we get more asthma attacks. We also get more asthma and lung problems being triggered because the heat impacts plants and trees and flowering, and our allergy season starting earlier. So all of these things happen. Traumatic injuries, water, and of course, our emotional stress. And we'll go into some more details as we go through. Heat is listed as the number one weather related killer. And in Florida, we average about 25 days per year where the feel like temperature is over 100, but that has changed because we're already seeing a rapid increase as our planet warms up. And as the temperature increases, we see more heat illness, more what we call heat stroke, when the body gets over 105 degrees. And when we get to 108 degrees, your body starts killing, disintegrating, the muscles start dying, and we see death. Just we're outdoor workers because they're also moving a lot. Their internal temperatures going up from their activity. Then you put the outdoor temperature. So it doesn't take a lot to have an outdoor worker who's physically fit, well, have problems with heat. And elderly people, when the heat index starts feeling at 100 degrees, children, elderly just cannot handle the heat as well. And by the time you hit 105, you're in major danger. Number one weather related killer. And again, we go through the stages where you start feeling the little prickly heat, when then you start getting tired and heat cramps till you get to you feel exhausted, you're feeling weak, you may have little nausea, and then the worst is if you start losing some sort of consciousness, you're getting headaches, and you're getting more problems. And that's when we see the major heat health risk. We talked about asthma, but heat itself also increases the ozone layer level on the ground because heat increases that concentration, which then triggers the health illness. We see the trees flowering earlier, and when you see the rates of asthma in African Americans, Hispanic, it's not a surprise because you saw the pictures that Nkosi showed where poor people live, where people of color were relegated to live, are in areas that have a lot more heat, a lot more pollution, and that would then leads to the asthma. When we think of what else happens with heat, we're not the only ones who are responding. Mosquitoes are able to live in higher areas where they weren't before, and the heat causes them to replicate and hatch more, and then they pass on more diseases. So we're seeing more things like Zika, dengue, malaria moving up into the United States and especially throughout Florida. Flooding, again, you heard about the moisture, increased humidity, increased moisture. When it rains, it pours. And we so see what's happening right now in North Florida with that wobbly, wacky, we said wacky polar jet stream. So now we have that cold air all the way down. That is now increasing. So when it rains, it pours. When it in the winter, it snows, and we're having snow in Pensacola in that area. We see the impact on pregnant people. There's a lot of data, and we're having a talk in April just solely on pregnancy and the environmental factors. Mental health, we see an increase in anger, increase in depression, increase in suicide with mental health issues, especially when it's hot. Not to mention the sea level rise. We know with all this melting, the sea is rising. So many impact of climate change in human health as we increase the weather, the air pollution, the changes in the vectors, all of this creating so many health impacts. We talked about the vulnerable populations, the elderly, low income communities. People of color live closer to polluting environments than everyone else. You know, not in my backyard. That fight over the incinerator is happening in the 21st century. The rich folks say, not in my backyard. Where is it they want to place it? And that's another polluting. We know about the policies. 1619 was one of the biggest policies that defined people from sub-Saharan Africa. People with melanin production became enslaved and for centuries were relegated to less than. And the Jim Crow laws perpetuated this despite the release of slavery, and that told you where you could live. Now, there are solutions that you see the opposite effect. In the Preemption Act and the Homestead Act in the mid 19th century gave every European access to land, and they took it from the Native Americans. And all of that, you see in the end who has more agency and power to be able to protect themselves. Again, civil rights acts, Medicare, Medicaid, all these impact your ability to live. You've seen this is the Richmond and redlining, and it's sweltering. All the areas are sweltering. Low income and minorities communities live closer to pollution. They live in housing conditions like my anime that her air conditioner basically seeped out of the windows, seeped out of the roof because she did not have the insulation. And that means her light bill was higher and the energy burden is tremendous. Latin communities, Florida, California, Texas, very, very high concentration, lots of exposure, lots of risk for heat. In Central Florida, you saw those pictures. This is in 1986 to 2002. You see that red, you see the yellow, huge risk. And when you look at the impact of the policies and discrimination, you see that the people who are able to afford to help to adapt to this are the people who cannot afford to adapt, are the people who are living in conditions that are highest vulnerability. If you look at again income by race, lower wealth people, people of color will have an undue burden to deal with this problem. There are lots of solutions, and the solutions are shared responsibility from personal responsibility. It's not just one person, one answer. It's going to really be all of us together working on solutions. And one of the first steps is getting educated. And what we do in Florida Clean for Climate Action is that we educate and prepare. We're building on the successes of other collaborators in getting the word out about what's happening in Central Florida, what's happening in Miami-Dade County. We're engaging clinicians, we're giving CEUs, we're going to educate more community organizations. We're also going to educate lawmakers because we absolutely need the lawmakers to be on our side. Um, Definitely, we got to leverage academia for research and continued learning. These are all the things we do in FCCA. Please follow us on social media, but we need you to understand how high risk it is. Just look at the Central Florida, Orlando zip code. You see those urban heat islands, all the reds and oranges. Those are high risk areas. Those are areas of low wealth, and these populations are usually younger or a lot of elderly, low wealth, lots of heat. We will bring lots of literature out. We will teach you about how to track the changes, how to check the air quality, how to check the feel like temperatures, because this is what we're seeing. Because of what's happening in our planet, we are experiencing billions of dollars of loss. And the biggest loss is our health and the life. We need everyone to collaborate as much as possible. So we want you to share this message. Come on and talk with us more. Bring us into your meetings. Come to our churches. We can help get folks ready and prepared to win. This is one of my patients, Jorge. This is really him. He gave me the approval, got it all signed. He lived in an area of Miami on that concrete, in that small concrete block building with very little windows. His kidneys were deteriorating, and that is what we started to understand more of what's happening to our health. Please and follow us more on these sites. We want clinicians to get involved in doing this work, especially now that we have a administration that is unwilling to recognize what's happening based on the science, but we still have time to prepare each other. So thank you. And now we want questions and we want as much interaction as possible so we can move forward.